solve by factoring. So we're going to take a quadratic and we're going to learn how to solve it using the strategy of factoring. So we've already learned graphing, now we're learning factoring. It is definitely a much more strategic and accurate method for solving. So we're going to take the first example, solve 2x squared minus 11x equals negative 15, and we're going to solve it using the strategy of factoring. So before we can do that, though, remember that when you're factoring, you have to have everything set equal to 0. So get everything on one side of the equation. So I have to add the 15 and to one side of the equation to get rid of it here, and I'm going to add it to this side. So my equation is going to say 2x squared minus 11x plus 15 equals 0. Okay? So I basically just undid the negative 15 from the right side of the equation, added it to the left side, and now the right side of the equation has a 0. So everything is on the left. Perfect. And now I'm just going to go ahead and factor. And so this is an example of factoring a trinomial, since there are 3 terms. And this particular trinomial has a greater than 1. So that means we're going to have to go through and use a little bit of a longer process in solving. We have to do 2 times 15, and so that's a times c, remember from your notes before. A times c, 2 times 15 is 30, factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. There are your factors of 30. We need the set that's going to give us negative 11. So negative 5 and negative 6. And then we replace that middle term, recall? 2x squared minus 5x minus 6x plus 15. So we just replaced the negative 11x with those two. We're going to factor out from the first two, so factor by grouping. We're going to group the first two together, factor out the x. Leaves me with 2x minus 5. And then I have to factor out the second grouping, and I'm trying to create a 2x minus 5. So I would have to divide by 3, and I also need the first term to be positive and the second term to be negative, so I'm going to change the signs by dividing out a negative 3. It leaves me with 2x minus 5, and I certainly know I'm doing something right because I'm getting 2x minus 5 in both sets of parentheses. That's the goal. That's what we want to happen. So I'm going to take the 2x minus 5, and I'm going to set it out front as a factor. And then I'm going, what's left, remember, is the x minus 3, and that becomes your second factor. All right? So there, we factored it down. That's step 2. I have my 2 factors set 0. So now what you do is you use what's called the zero product property. And the zero product property says that when you are multiplying 2 things together and the answer is equal to 0, which it is in this case, then one of the objects, one of the numbers, or the other number, or both of them have to be equal to 0. If you're going to multiply them together and get a result of 0, one of those things has to be equal to 0. And so what we're going to do is we're going to figure out if the first parenthesis is the one that gives us the 0, what would x have to be? So we're going to say to ourselves, 2x minus 5 is the one that equals 0. What would x have to be? And I'm going to solve. So I'm going to add 5, right? And I'm going to get 2x equals 5. And then I'm going to divide by 2. And x equals 5 over 2. Okay? And then maybe that wasn't the one that equaled 0. Maybe it was the second one that equaled 0. So I'm going to say x minus 3 equals 0. What would x have to be? Now these simple ones, usually students can tell me that, well, obviously if it needs to be 0 and I'm going to subtract 3, I needed to start with 3. But if you don't know, you can just go ahead and clear the equation, and then you get x equals 3. So we're saying that the solution, this parabola, crosses the x at positive 3 and at 5 over 2, which is about 2.5. So we're saying at 2.5 and 3, this parabola crosses the x. And then the last thing you should always do is check your answer. And how do you check your answer? You would plug your solutions back into the equation and see if they work. And when I say to make sure that they work, that really just means that they give you an equal statement. That what happens when you plug that into the equation is that, yes, it works out and it's equal. Okay? So let's try this example. We're going to move the 18 over, so subtract 18 first. X squared plus 7x minus 18 equals 0. I need to factor the trinomial. This is one of those easy ones to factor because the a in front is equal to 1, and those are the great ones because you can just plop your parentheses down here, and you know you're dealing with factors of 18 that are going to give you the 7. So 1 and 18, 2 and 9, 3 and 6, and then you're looking for which set is going to give you negative or positive 7. So I'm looking for positive 7. Positive 9 minus 2 is going to give me 7. So x minus 2, x plus 9, and then again, your job at this point is to set those both equal to 0. X minus 2 equals 0. Add 2. So x equals 2. And then x plus 9 equals 0. Subtract 9, and we get x equals negative 9. So our solution, negative 9 and 2. We usually write them just like we would on the number line, so the least value first and then the greatest value second. Okay, so the point on the left of the parabola would cross at negative 9, and the point on the right side of the parabola would cross at positive 2. All right, let's look at this one. Subtract the 8x. 16x squared minus 8x equals 0. First thing I'm going to ask myself is that the difference of two perfect squares? Since there's only two terms and there's a difference, I'm going to check. Yes, 4 times 4 is 16. Yes, x times x is x squared, but there is no number that I would multiply times itself to give me 8, and neither is there a number that I could multiply by itself to give me an x. So not the difference of two squares. But I also am going to ask myself, is there a greatest common factor I can take out of those two? And the answer is yes. I can divide them both by 8x. So I put my greatest common factor on the outside. 16 divided by 8 is 2. And then x squared divided by x is x. And then 8x divided by 8x, remember, is not gone. It does cancel, but it equals 1. So minus 1 equals 0. And then you have to set both terms equal to 0. So 8x equals 0, divide by 8. 0 divided by anything is 0. 2x minus 1 equals 0, so I'm going to add 1. And I get 2x equals 1, and then I'm going to divide by 2, and I get x equals 1/2. So my solution in this problem is 0. And 1/2. So factoring is a key and a super easy strategy for solving, way easier than graphing. You just have to practice your factoring, make sure you're ready to go. Let's scroll to the next page and check out how to use solving by using the square root property. So we're going to go ahead and scroll the page up, and we're going to solve by using square roots. Okay? Solve by using square roots. So typically we use the square root property when there is no linear term. It's often used, not always, but often used when no linear term. Not always, but very often it's used when there's no linear term. So what do? You look at it and you think, is there a greatest common factor? No. Is it the difference of two squares? No. Is it a trinomial? No. Is it a perfect square trinomial? No. So there doesn't appear to be an easy way to factor it. So not otherwise factorable. Right? It's not one of those easy methods we've already learned. So this is what we do. we isolate the x squared term. So keep in mind here, if there is a greatest common factor, you will take it out and factor it and set both terms equal to 0. But since there isn't, and it's not any of those other cases we're used to using, we're going to isolate the x squared term. So we're going to add 180 to both sides. We're doing exactly the opposite of what we've been doing, which is to clear everything and make it a 0. We did that, and now we can't factor it. So we're going to move the 180 over there. 5x squared equals 180 over there on the old right-hand side. And now we need to isolate the x squared. So 5 and x squared are being multiplied, and to undo multiplication, we do division. And we get x squared equals 36. 180 divided by 5 is 36. To undo a perfect square, we square root it, because the root and the square are inverses of each other, and they cancel and leave us with x. So we need to square root both sides to undo that x squared. So I'm going to square root both sides of the equation, and x is going to equal 6. But x could also equal negative 6. Whenever you do the square root, you have to always take into consideration that negative value. Let's check it. Positive 6 times positive 6 is equal to 36. So that works. But negative 6 times negative 6 also equals positive 36. So this parabola crosses at both positive 6 and negative 6. Okay? So your solution here is going to be negative 6 and positive 6. So be really careful that when you're taking the square root, that you square root and check for both the positive and the negative value. And that is solving a quadratic by all of the methods of factoring.